Kalimantan represents one of the most incredibly dense and intricately complex pools of living biological assets on the planet. For decades, the global market has evaluated this region through a narrow lens, treating it as a warehouse for raw, finite materials like timber, coal, and minerals. This extractive model produces high-yield regional GDP, but that revenue relies on a mathematical illusion. It is profitable only because the vast majority of its operational costs are externalized. To accurately measure economic health, we use the universal wealth equation. Net universal wealth equals total productive capital minus all social and ecological liabilities. Extractive industries manipulate this. They spike the immediate revenue integer while expanding hidden liabilities exponentially, driving net wealth into negative territory. The financial gains, export revenues, roads, and formal jobs are highly visible. The uncalculated costs are pushed off the balance sheet: polluted water systems, the permanent loss of genetic resources, and generational health burdens. These hidden costs eventually materialize. This bright orange runoff contaminating the river system is a physical transfer of debt from private ledgers to the public. If an economic model is mathematically destined to deplete baseline wealth, it has to be replaced. But a sudden halt to extractive industries would trigger immediate fiscal collapse. The Universal Regenerative Economy framework offers a transition path. It generates revenue by actively restoring land, water, and communities rather than depleting them. True economic development must be audited across generations. This requires a structural shift, moving away from depleting finite stocks and toward actively engineering perpetual, compounding yields. To understand what is actually being lost, we must look at the microeconomic scale. Let's isolate a single hectare of rainforest to audit its baseline value. Based on an initial simulation framework, the moderate universal loss incurred from destroying this single hectare is 700 million rupiah. That valuation breaks down into tangible assets. Bioprospecting potential accounts for 125 million, while raw biodiversity and genetic resources hold another 100 million in lost potential. When the forest is cleared, systemic natural infrastructure is destroyed. This creates a 100 million loss in water and soil regulation and a 75 million loss in carbon storage. Crucially, this liquidates the raw inputs for future industries. Over 49 million rupiah per hectare is tied directly to natural pharmacy and biotechnology. The tropical canopy contains highly specialized biological structures, like these pitcher plants. Extinction eliminates these complex chemical compounds before they're researched or synthesized into medicine. When we take this per hectare calculus and apply it to a scenario of 16 million hectares of cumulative damage, the true scale of the deficit becomes clear. The indicative loss of universal wealth scales to 11.2 quadrillion rupiah. This is the physical reality of that missing wealth. When ecosystem degradation sparks peat fires, the state absorbs the hard financial costs of disaster mitigation and rehabilitation. The 11.2 quadrillion figure represents a massive, unpriced financial debt quietly transferred to the public ledger. The primary argument for maintaining the status quo is the high short-term profitability of extractive industries. This chart compares the economic trajectories of extractive and regenerative models over a 30-year timeline, tracking the net present value per hectare. The extractive model, curve A, delivers rapid early revenue spikes, tracking toward an indicative net present value of 204 million rupiah over 3 decades. The regenerative model, curve B, requires upfront investment. It crosses into profits slowly, growing at a steady 2% annually, to reach an indicative value of 94 million rupiah in that same window. Strictly within a 30-year cash flow window, the extractive model mathematically outperforms the regenerative model. At year 30, the extractive model hits a structural limit. Once the finite resource is gone, revenue generation ceases entirely, while an estimated 80 million rupiah in rehabilitation liabilities hits the ledger. The regenerative model retains its core capital asset, the land itself. It continues to generate compounding yields well beyond the 30-year mark. This is the end-of-life reality for the extractive approach. The productive land asset is liquidated, requiring massive capital injections just to stabilize the soil. A recovered peatland ecosystem functions as a mature, self-sustaining biological engine that continues to function as a highly productive economic asset. The extractive model functions as a payday loan taken out against the region's land value. The regenerative model operates as a compounding, perpetual trust fund. The regenerative model functions as a highly active, technology-driven industrial engine. It relies on scaling ecosystem restoration, local supply chains, and specialized downstream processing. The first pillar is natural pharmacy and bioindustry. This involves processing raw biodiversity locally into standardized extracts, biomaterials, and high-value biotech exports. The second pillar, multistrata agroforestry, combines timber, food, and medicinal crops into a single landscape. This diversifies agricultural risk and provides distinct income streams across short, medium, and long-term horizons. The third pillar transforms ecosystem restoration into a specialized service sector. It creates permanent industrial jobs in nursery management, carbon monitoring, and hydrological engineering. This requires a shift in labor roles. Local communities must transition from providing manual labor to becoming equity owners in cooperatives, brands, and the intellectual property of their traditional knowledge. A regenerative economy engineers nature's restoration to function as the primary driver of regional economic growth. Pragmatic policy must account for the fact that a sudden halt to extractive industries would trigger mass unemployment and energy crises. Decoupling the regional economy from resource depletion requires a 5-stage transition roadmap. Stages 1 and 2 prioritize auditing existing concessions and internalizing costs by enforcing full reclamation bonds and carbon pricing. Stages 3 and 4 focus on rapid diversification into bioindustries while reducing the local government's reliance on mining royalties. This leads to stage 5, the achievement of full regeneration, where regional economic growth is uncoupled from deforestation. Underwriting this transition requires a critical financial engine, the Kalimantan Endowment Fund, or Dana Abadi. The fund operates on a strict rule. Every unit of a non-renewable resource extracted today must generate an equal or greater productive asset for the next generation. Royalties from finite resources are siphoned into a locked trust, which finances perpetual assets like research laboratories, clean energy grids, and human capital. Verifying this transition requires auditing net wealth rather than singular metrics like GDP, tracking water quality, intact carbon reserves, and household equity. Kalimantan can achieve regional prosperity while simultaneously expanding its ecological capital. Rebuilding the region requires a structural shift, transitioning from liquidating natural stock to engineering perpetual productive capacity.